Array tester. Purpose of the array tester. The array tester involves reasoning of integer arrays and accessing columns and rows to check what is considered a Latin square. There are two parts to this program, and for each part you will construct static methods. First, let's discuss what a Latin square is. So, Latin squares. A Latin square is a square created by a series of numbers, each never appearing in the same row or column more than once. Can you see the pattern of how this is done? So we're shown here, what's going on, and it says this is a Latin square, this is not a Latin square, because the second and third column contain duplicate values. So essentially what I'm seeing is that every row and column of this square contains the numbers 1 through 3, or rather, 1 through however long, whatever the length of the row or column is. And in addition to that, they're not necessarily in the same order. It's just that they contain all the values. So, for example, you have 1, 2, 3, 2, 3, 1, 3, 1, 2. So, part A, instructions. Write a static method getColumn, which returns a one-dimensional array containing the elements of a column in a two-dimensional array. The elements in the returned array should be in the same order as they appear in the given column. The notation R to the RC represents the array element row, the array elements row at row R and column C. For example, consider the following code. So we have this definition for a 2D array, which is a 3 by 3 array, so 3 rows, 3 columns. And so what they're saying is that array tester.getColumn should return, if called with this 2D array, and with 1, it should return the column 1, 4, 5 as a one-dimensional array. Makes perfect sense. And we also have part B here, but before we go into part B, we'll just focus on part A and just get this done. So let's just start, writing in our new file. So public class array tester. And yeah, we'll just start writing this part A. So, we'll just write it as a public static method for now. And it seems like here what we're going to be doing is returning an int array, and that's the return type, and we will call this get column, and we need to make sure to specify that the first argument will be a 2D array, so int array, and we'll just call this R2D like they do in the problem in this description, and we will call the second argument C for column. So this can just be a simple integer, C for column. And there we go. So yeah, now we need to go ahead and return this array. So we're going to want to create a new array. And the way we're going to want to do this is we're going to want to say int array, and this will just be the result, or yeah, we'll call this the result, equals a new int array of size. And for this, what we can do is we can say R2D, right, access the first row and access the exact column we're interested in. Or rather, because this is a square after all, and I'm pretty sure we can assume this will always be a square. Containing the elements of a column in a two-dimensional array. Yeah, I mean, we're writing this code specifically for Latin squares, so since we are writing this for Latin squares, I think we can actually go ahead and just say R2D length, because we want them to have the same length, because when we're saying R2D length, what we're essentially saying is, what's the number of rows that you have, which is equivalent to saying, what's the size of your columns. So now that we have that, we add a semicolon, and we can go ahead and write the actual code. So we're going to need a for loop for sure. So for int I equals 0, as long as I is. So we're going to want to think about how we want to do this accessing. So if we want a column, what that means is, when we're accessing our 2D array, we're going to keep the value in the first bracket is going to be representing the row, so it's always going to be changing. Whereas the second value, which represents the column, is always going to be this value C. So we actually don't need a double for loop. We just need the for loop to iterate over the rows. So for int I equals 0, as long as I is less than r2d dot length I plus plus. And then what we can do inside of the for loop is we can say result, and remember, result has the r2d length, so we can just access result with I equals r2d I at c, and c is a constant. So then this will fill in result with our, the column that we're interested in. And then at the end, we can just go ahead and return the result. So that should be a working method for this get column, and we'll just save it and compile it just to make sure that we don't have any compilation errors so far. And nope, seems like it all compiled correctly, so we can move on to part B. So part B says write the static method is Latin, which returns true if a given two-dimensional square array is a Latin square, and otherwise it returns false. Now, oh, whoops, I accidentally added in a character there. And so yeah, and let's check if we have any other slides. So we have some final program descriptions. So we have a main method description here, used to call two methods, initiate original 2D array and print result. And we also have our get column method. So right, and then we also have this other method that they mention here, which is a public static boolean has all values. So has all values, and we pass in two arrays. And essentially what this is doing, it's saying here, you return true if and only if every value in array 1 appears in array 2. So precondition, array 1 and array 2 have the same length. That makes sense. Postcondition, array 1 and array 2 are unchanged. And so you may be wondering, how would we use this method, has all values? why would it make sense to have a method like this? So essentially the purpose of having this method is that, remember what we said earlier about Latin squares, no matter what the row in the column is, it should have all the values between 1 and the length of a row or column. So, it doesn't matter what it is, it should have 1, 2, 3, 1, 2, 3, 2, 3, 1, 3, 1, 2. The order doesn't matter, but it should have all the values. So that would be, the point of having a method like this. And so what we can do is we can go ahead and focus on writing this method right now. So let's start typing that up. So public static boolean has all values, and then we have our two int arrays. So int array, and I'm just going to call my first one R1, and then int array R2. Okay, and now what we have to do is we have to write our code and, figure out if, all the values are present. So the way they describe this is return true if and only if every value in R1 appears in R2. So a way to think about this is we want to loop over the values of R1, right? And we want to say, okay, let's take the first value, and then we want to say, okay, does this value show up somewhere within R2? If it does, then that is great. And how do we check if it does? Well, we have to iterate over all the values of R2. So from the sound of it, we're most likely going to need a double for loop, like a nested for loop. So for int I equals 0, as long as I is less than, and we'll just say R1 dot length, I plus plus, and then what we will say is for int j equals 0, as long as j is less than R2 dot length, j plus plus. Okay, so right, so like we were saying earlier, we have the first value of R1, and we're checking to see if it is somewhere within R2. So how can we figure this out? So a good way of going about this is just saying declaring a boolean in this first outer for loop, and we can just call it has value, and we initially set it equal to false, because at the moment we have no idea if the first value of R1 will show up in R2. And then what we do is we say the following. We say if R1, oh, my mistake, forgot the parentheses. If R1 I is equal to R2 j, then what that means is we found the value from R1 in R2. So we can say has value equals true. Now, the reason we don't just go ahead and return true is because we've only checked one particular value of I. If we just return true, then we wouldn't know if the other two values are also present in array 2. So this is why we have to use this extra variable. And then after this inner for loop, what we want to do is we want to do a check on this has value. So we want to say if not has value. So if we couldn't find, the first value of R1 within R2, then we know for a fact that we've already failed. So we return false. And then so if it doesn't have the value, we return false. And if we get through the entire double for loop and we haven't hit this clause here, then essentially what that means is that, we were always able to find every value of R1 within R2. So that means that we can return true. And so yeah, that should be everything we need for this has all values method. So now we can save this, then we can press Control B to compile. And perfect. So this is important because, my mistake. I made a very simple, silly mistake, and I can fix all these right now. I've been capitalizing my Boolean values, which was silly of me. So, false, true, pretty quick fix. So yeah, hopefully that will fix. So Control S, Control B. And this is why it's a good idea to, try to run or at least compile your code while you're coding it, after you finish like a method or something like that, because it'll let you catch errors early on, and it'll be less frustrating later once you finish all of your code. Okay, so now that we have this method working properly, we can go ahead and look at what is next that we should have. So obviously we know about is Latin. And the next thing that we have is contains duplicates. So what this method seems to do is the following. It says returns true if the array contains any duplicate values, false otherwise. And so this makes a lot of sense. You do not want, any of the rows or columns in a Latin square to have duplicate values, because by definition, it's not supposed to have that. So having a method that could check for this makes a whole lot of sense, because those are the two, essentially, these methods that we've defined has all values, and the one we're about to find contains duplicates. Those are essentially all that we need to properly define a Latin square. What we need to properly define a Latin square is we need to say, okay, does every row and every column have, the values 1 through 3 or 1 through n, depending on, how big a row or column is. And the other thing we need to check is, do all the rows and columns not contain any duplicates? And if those two conditions hold, then the square is a Latin square. So we can go ahead and start writing this contains duplicates method. So public static Boolean contains duplicates. And we have an int array R. and our curly braces. Okay. So again, return true if R contains any duplicate values. So we want to report back whether there are duplicate values, not about whether there aren't any. So what would be a good way of going about this? So what we could do is we could, iterate over the array. So we take the first value of the array and then just quite simply just compare it to every other value of the array. So essentially what we're saying is grab the first element of the array, and let's assume, for this small example where I'm trying to explain that it's three element, rows and columns. We take the first element, we compare it to each of the other two, and then that would be enough, because with that we have established, whether one is the same as, whether that first element is the same as 2 or 3. Then what we could do is we could compare 2, so the second element, to the third element and the first element. But keep in mind, when we're saying we compare it to the first element and the third element, we've already done a comparison with the first element, because we know from checking with the first element that it is not equal to the second element, so obviously the second element is not going to be equal to the first element. So in actuality, we just have to check everything to the right of that second element, which would be the third element. And so from this, you may sort of be able to see where I'm getting with, the code. So in my mind, I'm thinking of a double for loop. But the catch is that this nested inner for loop doesn't start from 0, but it instead starts from the very next element. So let's start writing that out. Okay, so for int I equals 0, as long as I is less than r dot length I plus plus, we need our curly braces. And we're going to declare another for loop. So for int j equals, now we want to go with the element that is 1 after I. So for int j equals I plus 1, as long as j is less than, again, r dot, or rather, as long as j plus 1 is less than r dot length, so j plus 1 is less than r dot length, then j plus plus. So now you see what I'm doing here. I am, the outer loop is going over the entire array. The inner loop is going over everything after where the outer loop is currently analyzing, or, processing. So, yeah. So now what I would have to do is I am interested in whether or not this array contains any duplicates. So as soon as I find a duplicate, I can just return true. So since that is the case, I can simply go ahead and say if Ri is equal to Rj, right? If Ri is equal to Rj, then I immediately know that we found a duplicate value, and that means that I need to return true. And otherwise, if we can get, through this entire inner for loop without returning true, that means we found no duplicate values when we checked the first element of the array against all the other elements. So now we have to check the second element against all the other elements except the first element, and so on and so forth. So essentially, if we can get through the entire outer for loop, that means there were no duplicates. So we just return false. And that should be it for that method. So now we can go ahead and save this and Control B to compile. And as you can see here, we actually ran into a problem. Oh yeah, silly me. I keep capitalizing the Boolean values. I really shouldn't be doing that. But again, it's a very simple to fix error. So there we go. Perfect. So now we can continue writing our code. So the only method that we have left is the isLan method, and well, I mean, of course we have the main method left as well, but the main method is more just about testing out, the functionality of everything else. So, oh, whoops, sorry about that. So we can now start writing the isLatin method. So public static boolean isLatin. We need a multi-dimensional integer array. Okay, so we have already talked about, how it is that we could use, the two methods, specifically has all values and contains duplicates to determine if something is Latin square. And then of course, get column is necessary because at some point, we have to check the columns as well. So now it's just a matter of writing out code that essentially iterates over all the rows and checks, both, that contains duplicates and the has all values. So the first thing that we are going to want to do is, for the has all values method, we specifically want to say that array 1, right, should be having, all the values from, 1 to n, with n being the length of a row or column. So we're going to want to define what this is because we're going to be using it, to compare to. So we can just, go ahead and do this. So int array, and we can just call this, all values equals a new int array, and this new int array is going to be, square we know for a fact is equal number of rows and columns, so we can just say it's going to be square dot length in terms of size. And then we're going to want to write some code to actually fill in the values. So for int I equals 1, as long as I is less than or equal to, yes, as long as I is less than or equal to all values dot length, I plus plus. And then what we will do is we will say all values I minus 1, because remember, arrays are 0 indexed, equals I. Pretty straightforward. So, right. And we should just add in a little bit of explanation for what's going on here, because it might be unclear. So, define a correct row or column. Okay. So now we can go ahead and focus on the other part of the code. So, we're going to have to go over all the rows and over all the columns. So we could just have two separate for loops, one for the rows and one for the columns. It seems like the logical way to go about this. So, yeah, so that's exactly what I will do. So for int I equals 0, as long as I is less than. So if we want to go over all the particular rows, we can just say square dot length I plus plus. Okay, now the condition we want to check for is that we won't know if it is truly Latin square until we've iterated over all the rows and columns, hence iterated over this for loop and the next one that we're going to write. So instead we want to check anywhere where it trips up, right? Where it does not hold true. So a good way of doing this, if, or at least an easy way of doing this, is to write out your if statement as if you were checking if it was a Latin square. So if it's a Latin square, what we want to see is that what we want to see is that there are no duplicates. So contains duplicates should be false. So if not contains duplicates, and the array we want to pass through is just square I, right? And so if it does not contain duplicates and it has all the values, so let's go further down, and has, I think we capitalized all, yep. So has all values, and so we have our all values along with square I. So this is the condition we want to check if it is true. But if it is not true, we essentially just want to say this same thing, but with a not in front of the entire thing. So that is exactly what I will do. So this entire condition is checking if the condition is not fulfilled. And if it's not fulfilled, then what that means is that we can return false, because we automatically know that it is not a Latin square. And we can do this same procedure for the columns. So for int I equals 0, and you know what, now that I think about it, something that's interesting to consider about this, I'm about to write out a for loop, and I'm starting to realize that it's going to be very, very similar to the for loop we just wrote out. So when you realize that this is happening, it's always good to think about, well, can I just combine these two for loops into, one simple for loop? And usually the answer is that you can, so I'm going to look into how I can do that. So I already have one if clause, and it seems to me like the way to combine these for loops is going to be to add another if clause. This second if clause is going to be going over the columns, because remember we have the same number of rows as number of columns. That's why we can combine these two for loops. Otherwise, we would not be able to do so. So if we go back for a second to the get columns, right, we need to specify a 2D array, and then we need to specify the particular column. So this is actually pretty straightforward. In fact, the code would be very, very similar to the current if statement, with, you know, some slight tweaking. But since this, you know, if statement is already quite long, I would rather copy it and put it on a new, you know, line on its own if statement. So now we have this new one. So what we need to change for this new one is we no longer want to pass through square I, because that's a row. So we definitely want to get rid of this. Instead, what we want to say is, we want to say get column, and we want to call this with square as the 2D array, and the column is just going to be I. And that should be all the parentheses we need. So it contains duplicates, get columns. Okay. And then that way we're checking if the column has duplicates. So this one is checking if the row has duplicates. This one's checking if the column has duplicates. And then accordingly, we want to look up here at has all values. So instead of looking at the square, we also want to look at the column. But something that I'm realizing right now is that if we make this call to get column, square I twice within the same if clause, it seems sort of wasteful, So it might be a lot more efficient to actually define the int array separately as just call, and then place the call to get column here. And this will result in, slightly more efficient code, which is nice. So that way we can just type in call. And it's also a lot neater, too, than writing out, that whole phrase of get call square I twice. And there we go. So that should be enough for that. And then I, of course, have to add my curly braces and return false. Okay. Perfect. And now the last thing I would do is at the very end of this for loop, I would just return true. And that would be all of it. And then we can add a comment for this too, because it could be a little confusing about what we're doing here. So iterate over all rows and columns. Make sure that none of them have any duplicates and that they all contain the necessary values. So that makes sense. And yeah, so then now we can save and compile just to make sure that everything's okay. Okay, so This is good that we're checking because it seems like we forgot a parenthesis somewhere. So where did we forget our parentheses? This can always be a bit tricky. Let's see. Square I right. Hmm. Seems a little strange to me because I don't think we forgot the parentheses, but I will add another one to be sure. Oh, I see. We're missing the parentheses for that extra not that I added, and I'd imagine, yep, since I copied this code for this if statement, that I also forgot the parentheses here. So there we go. Perfect. So that is now fixed. So now we can go on to writing the main method. Okay, so for the main method, we're told that, oh, whoops, it was further back. Here it is. So we're told that, we should use it to call the methods, initiate the original 2D array, and print the result. So in my opinion, it probably makes the most sense to just go ahead and use the examples that we were given. So yeah, so that's exactly what we're gonna try to do. So let's define our int array. So R2D equals, actually it probably makes more sense. Yeah, let's put this example. Yeah, that makes more sense. Okay, so we need our brackets, we need a semicolon, and then we need our 3 rows. And now we can start defining them. So 1, 2, 3. And this should be 2, 3, 1. And this should be 3, 1, 2. And we know that this one should definitely be a Latin square. So we will go ahead and just simply print out if it is a Latin square or not. So system.out.println is this a Latin square? And then we can do and then we can just do a concatenation and call is Latin on the R2D. And yeah, that should be enough to test out and figure out, if we wrote our code correctly. So Control S to save, Control B to compile. Whoops. It looks like, yes, I see. Forgot the double bracket. So Control S to save, Control B to compile again. Okay. And now we can run our program. So is this a Latin square? And apparently it worked correctly. Our code had no issues figuring out that it was not a Latin square, or that it was a Latin square rather. And let's see if we can change this up, and why don't we define the second one and check to make sure that it returns false for that. And we could just do a copy and, rename this to square and fill in the new values. So 1, 2, 3, 2, 2, 1, 3, and then 3, 1, 2. Okay. And then we can just take this print statement and also copy this. And And then we just need to get rid of R2D and replace that with square. So now we can save, Control B, and Control R. And perfect. So it says false, which is exactly what we expected. So it seems like our program is working correctly. Of course, if you feel compelled to do so, you can run some more tests, try out some more square patterns, and figure out if it really works as well as it should. But I'm fairly convinced by these two examples that it works.